Hello everyone, welcome back to MGF1106. In this video, I want to go back to the counting principle, which is we already talked about in the previous, at the beginning of the chapter. We discussed the counting principle. We know that if we have an event A with a certain number of with m way of doing, and event B with n way of doing, then based on the counting principle, we know that we just need to multiply m times n. We have give you the total number of options. The which just give you the total number of possible outcome. Later on, we will talk about the probability. We call that the sample space. Now, the counting principle actually is based on the root. Uh, there's a root. There's the foundation. It helps understand the counting principle. And in this video, we're going to discuss that foundation. We discuss that root. That root that is nothing but a diagram. So we call that tree diagram. Okay, so in this video we'll be I'm going to be talking about the tree diagram, and let's see how we're going to set a tree diagram to find the total number of possible outcome, the element of the sample space. Then let's see how we're going to use that to calculate the probability. Okay, so let's get started. So I'm going to put here. I think I'm going to jump to the next page. Okay. Put here tree diagram. Okay, tree diagram. Okay. Okay. Now I think I'm gonna go jump into the first example right away. I think it is gonna help us to understand what tree diagram is. Actually, just the way we count the number of way to do things in an event. So I'm gonna just jump into the example right away. I think it's easier to understand. So I had a problem like this. At Johnny restaurant. Restaurant. Okay, I don't have a picture for the problem, so I just go ahead and write them down. And each dinner special consists of an appetizer, appetizer, a salad, and entree, whatever it is. Okay. And the choices of appetizer, salad, and entree are listed below. The choice of appetizer, salad, entree listed below. So we give you some information like this. So for the appetizer, so we have two different appetizer. We have bruschetta. I don't know what is that, how we pronounce this appetizer here. Bruschetta, I don't know. Okay. Then we have antipasto. So it looks like it's Italian food. Then for the salad, so we have only two different type of appetizers. We have Caesar salad. Then we have green salad. Okay, so we have two types salad over here. And then for the entree, we have ravioli, we have salmon, we have lasagna. Okay, now the question is, okay, determine number of points in the sample space. Okay, then we construct a diagram. Construct diagram. Tree diagram for this scenario. And when we construct a tree diagram, I believe that we can find a sample space also. Then we want to find probability of Bruchetta for the Bruschetta. I don't know how to pronounce this word. Bruschetta. Okay. For appetizer. Then part D. We want to find the probability. The customer select green and lasagna. Green and lasagna. And for part E, an entry other than ravioli. Entry other than ravioli. Alright, let's see how we do this problem, okay? Okay, so in order to calculate the number of elements in the sample space, which is the number of points, we're going to use the counting principle because because this problem, the tree diagram, is based on counting principle. And the counting principle is based on the tree diagram. So both of them is kind of the same thing. So we already talked about the counting principle in the previous video. So I'm going to just go ahead and use the counting principle here. So so let's see how many samples, how many elements in the sample space, how many points in the sample space we have. Okay. So I'm gonna do S over here, sample space. So we have a two-type appetizer. So if we go ahead and apply the counting principle, we have 2 times multiplied by 2 times Caesar multiplied by 3 times. So totally we have 12. Okay, 12 different dinner. Okay, 12 different dinner we can choose. Okay, and the reason we have 12 is actually based on the tree diagram. Go like this. So you see that for appetizer, so we know that we have 2 appetizer. So we have this. I don't know. We need to write up. So okay, let's erase. Let's create like this. So we know appetizer. We have 2 types. We have bruschetta. Bruschetta, and we have antipasto. Okay. Then for the salad, we also have 2 of them. We have Caesar, and we have Caesar, and we have green. Then we have ravioli. We have salmon. And we have lasagna for the engine. Now, in order to create the tree diagram, you just need to draw this, draw the arrow. This one go to this go to that. Okay, and we can do this one go to this, and this one go to that. Okay, okay, then all we can do, this one over here, then this one up here, this one here, oh, this one go for this. Okay. So you see that for bruschetta appetizer, that is the number of dinner we can have. And for antipasto, we're gonna use different color. So I'm gonna use this. It's also go to Caesar, or this. If you go to Caesar, okay. Okay, we go for Caesar. Then you see the Caesar can pick ravioli. It can also pick salmon. Then can it also pick lasagna. Okay. And if antipasto go for green, then green can go for ravioli. It can go for salmon, or it can go for lasagna. So let's see, we go ahead and list all the elements in the sample space. So the sample space will be, okay. So we have B represent bruschetta, Caesar. So we have BC, BCR, or BCS, or BCL. Okay. Or we have B, BR, R represent green, BR, G, I'm sorry, G represent green. So we have BGR, we have BG salmon, and BG green lasagna. Okay. Then for antipasto, we have ACR. Sorry, today I don't feel good, but I have to make the video for you guys. We have ACS. We have ACL. Then we have AGR, AGS, and AGL. So we know that over here we have 12, right? So let's cut it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See that? So we have 12 options. We have 12 different dinner. Okay. So this is a tree diagram right here. Okay, this is my tree. I mean, in your textbook, the tree diagram, it looks very beautiful, but that's okay. You know, the tree diagram could be like this as long as you understand what tree diagram for. Okay. The bad thing about tree diagram is this: what if you have like instead of having only 2 appetizers, you have like 10 appetizer and 10 salad and 50 entree? Then think about it. Your tree diagram pretty messy, right? So that's why we need to have we must use Cartan principle. But you see that the Cartan principle is actually come from it based on the tree diagram concept. Okay. Now we're gonna go ahead and calculate the probability. We need to calculate the probability of getting of getting a bruschetta as the appetizer. So the probability here will be, let's see, how many bruschetta in this option here, in this combination? 1, 2, 3, 4, 5, 6. So we have 6 over 12, right? We have 6 over 12, which is 1 over 2. The reason we have 12 because it's a sample space. Okay, the total different outcome. Okay, we already learned the concept of probability already. And for this, we want to find green or and lasagna. So green and lasagna. Green and lasagna. So which one has green and lasagna? Green lasagna right here. Okay, see that right here. Green is lasagna and green lasagna right here. So we have only two options right here. Okay, so we have 2 over 12, which is 1 over 6. Okay, and for probability of entree other than ravioli. Okay, so entree other than ravioli. So we know that we have only 3 entrees, but it's other than ravioli, so mean salmon and lasagna. So either salmon or lasagna will be included. So then we have 1 is salmon, lasagna, 1, 2, 3, 4, 5, 6, 7, 8. So 8 over 12 will be 2 over 3. There you go. Okay. Pretty easy, huh? Okay. Let's do another problem. Let's see. Okay, how about this one? So this is a tree diagram. Oh, example 2. So in example 2, we have we have the table look like this. So we have this is I'm kind of lazy right out on the problem, but that's okay. So Mr. and Mrs. Frank just move into a new home, into a new house. Okay, they're going to purchase 1 tree, 1 shrub, and 1 bush. We want to purchase 1 tree, 1 tree, 1 shrub, and 1 bush. Okay, and this is the number option they have for tree. So for tree, we have different type of tree. We have dogwood, maple, dogwood, maple, maple. Then we have birch. Then we have shrub. Then we have forsythia. We have holly, and we have juniper. And for the bush, we have common, sensation, and primrose. Okay, sensation and primrose. Okay, so the question is kind of the same thing. For the first two part, we want to calculate the number of points in the sample space. Create the For part B, we want to create the tree diagram. For part C, we want to find the probability of a maple tree. Then for D, we want to find the probability of a dogwood and holly shrub. Dogwood. Okay, and holly shrub. And for E, we want to do a bush other than sensation. Okay. Okay. So let's see how we do this. You know what? I think I'm gonna leave it here for you guys to go ahead to do it yourself. Because if I do it, then you guys don't have chance to practice. So based on the first example, I want you guys to go ahead and try to do it yourself right here. Because the question is kind of the same. So I want you to go ahead do it yourself and try to, when you draw the diagram, the tree diagram, try to use different colors so that you know it, and it's easier for you to list all the element in the sample space. Okay, all right. So I think we're gonna just let you guys do it, and if you cannot figure it out, then go ahead and ask me under the comment section of YouTube. Okay. But I'm sure that you guys can do this. Just basically just mimic the example one, right? Okay, so I think I'm gonna stop the video here. This video kind of very easy. It's not really that hard. So if you have any question, please put a comment in the under the video. Then I'll try to reply as fast as I can, or you just go ahead and send me the message in Canvas. Then I'll send you back the replies very soon. Okay, I'll see you next time.